Welcome to BeeGraphy. In this 7th tutorial, we are going to combine two of our older scripts together. One of them we created a twisting tower and the other one we did the attractor logic. In this one, we are going to combine both of these scripts together. So we'll take some parameters of the twisting tower and connect it with the attractor logic and see how that works out. So I'm also going to be demonstrating how you can take some nodes of a different script and simply copy paste, kind of migrate it in your current script. So all you have to do is open up a blank canvas, and then on a different tab you can open up beegraphy.com, log in of course, go to your scripts that you need to extract the components from. So in our case it will be attractor logic. So let's open that up. And on the third tab, I'm going to open up the twisting tower. So it would be this one. Right, so we've covered this in the third tutorial and fifth and sixth tutorial, how to do the twisting tower, how to do the attractor logic. And what I'm thinking of doing is, let us take the entire script. I'm doing Control C and then Control V. Wait. Control C, then Control V. Yeah, perfect, it worked. All right, so we've got that script here now. Similarly, in this we don't need everything. I'm just going to take a part of it, like the attractor point, the square grid, the distance of 2 points, and then we're going to use the distance that comes out and connect it to the parameters of the twisting tower. I'm selecting this, copying this, and then I'm going to paste it over here. Awesome. So now the idea would be, we have this square grid, right? So we're going to reduce the count of all these squares, and then we'll have a tower on each of these points, at each of these points, and the parameters of these towers will be connected to our attractor logic. So we know that the square grid produces points and the squares. We don't need the squares. I'm going to hide this. I'm using this relay as a display node, right? So that I can only see the points. If I do not have this, we won't be able to see the points. Okay, so we can see those points. Let us reduce the number of points so that it's not too much for the computer to calculate, and let us space it out a lot more than just 10. So let's put in 50 over here. Let me check if the live calculation is on. I'll just turn on the live calculation so that we can see how far we are going. All right, so the padding is 50. Again, padding is just the spacing between all these points, spacing between this grid of points. The sphere that you can see here is the attractor point that you can move. For demonstration purpose, I just kept it like this, but you can separate it out so that it is much more in your control wherever you want to place it. Okay, now somehow we need to connect these two, right? So this point should become the origin for my base of twisting tower, because at the end the entire twisting tower starts off at the base, this rectangle by center, and then the entire script is building on that, right? And the rectangle by center, we've got this origin, which by default is 0, 0, 0, and if you change this, you will see how the entire tower is moving. So the origin is acting as the origin of our twisting tower, the base, the center of the base of this twisting tower. Okay, so let's get it back to 0. Now you could see that it is taking time to render for the geometries to be created, because there are a lot of geometries that are there. So what we're going to do is reduce the number of floors before populating it throughout the grid. There is angle of rotation, number of floors. Let's reduce that. And let us reduce the number of the grid points by one more. Yeah, because this is just for demonstration purpose, so we wouldn't want to wait a lot of time for the computer to calculate things. Now you know that this origin means the origin of our twisting tower. So we are going to take these points, right, and put it inside the rectangle by center. Okay, let me directly connect it here. So what has happened is we see some error popping up. Let me just keep it here. And I'm glad this popped up, because it will allow us to understand data structure even better. So we need to graft all these points. Let's first check what is coming out, how the data is structured as it comes out. So we've got like these 3 points and then 3 points. And you can see that it is considering these 3 points as part of a single tower. What it actually needs is that all of these points are branches. They are not clustered as rows. So it's very simple solution. We are going to flatten so that all of these points become one long list of 9 points, and then for each of them we'll put them into branch. If you remember, we had already accidentally done this and then we had reversed it. So let me show you what I mean. So there is flatten tree. Okay, and I'll show you by each step how the data structure is changing. And this is like a nice small list of items, so it will be easier for you to understand. Right, so right now, how is the data structured? It is branched. As you can see, it is dotted. There are 3 branches. Each branch has got 3 points. Right, so this is one branch where there are 3 points inside. And this is a second branch with 3 points, and then the third branch with 3 points. I'm going to flatten it. So let's see what pops out. Now we see that there is one list. There are no branches. There is just one list of points, of all the 9 points together. This also won't work, but just for demonstration purpose, let me show you what will happen if we do this. You see, it is considering all these 9 points as part of the same tower. So it is doing this crazy geometry thing. What we need is each of these points to be a separate branch of their own. I'm going to type in graph tree. Yeah, I'll keep these panels so that you can compare how the data structure is changing. I'm really glad that this happened, so you can see step by step how the data structure is changing and why it is important to understand it. I'm going to create another panel We're going to see what we get here. Perfect. Okay, so even if I do this, like close all these branches, you'll understand it even better. Initially, when we create the square grid, this 9 points, this data was created in this format. 3 branches. If you open a branch, we get 3 points. Each branch has got 3 points. Then we flatten it. We've got just one list, no branches, just one list. And that's why you can see all these lines are solid, thick lines. Right? I have to just put one, like open one drop down thing, and I get 9 points. And then I'm grafting it and creating branch for each of these points. You see, we get 9 branches. Each branch has got 1 point. Here we've got 3 branches. Each branch has got 3 points. I think I've reinforced it enough now. And let's see the magic happen. I'm going to take these branched points and we'll see 9 different towers popping up in just a bit. Perfect. So they are completely identical because all of them have got the same data going inside. So we have successfully combined and connected one aspect of the attractor logic with the twisting tower. Now to connect certain parameters of our twisting tower, which is, let's say, number of floors or angle of rotation would be good. Let's just do these two for now. Yeah, so we're going to connect these two parameters with their distance from the attractor point. One thing to note is the number of floors should always be a round number. So we are going to use a round node. So we'll, whatever fraction number we get according to the distance, it will be rounded off and then put it to number of floors. Angle of rotation can be any fraction, so that's fine. Other than that, I think we are good to go. I'm afraid that there are like too many geometries that are turned on right now. So let us disable certain geometries, work with our script so that it is very fast, and then we'll enable them if need be. So I think first of all, I'm going to turn off all the materials. I'm disabling them. I'm not hiding them. I'm disabling them. So, because if I'm hiding them in the background, it will still continue to work. On the other hand, I can enable all these basic geometries. There is this, there is this. Yeah. And then there is the loft. So first of all, we'll search for the distance between 2 points and we will see what is coming out of it. What is the number that is coming out? So these are big numbers, 92, 38, 123. These can be used for the angle of rotation, but it should be very fine. So it should be like 6 degrees, 5 degrees. Currently we've got 6 degrees and we are getting this rotation. If I increase it by a few degrees, it's calculating. And you can see that the twist is a lot more than before. And as you can see, it is still taking a lot of time. So I'm planning to remove balconies. Okay. And we have got the slabs. Let's remove the slabs for now. Yeah. Okay, so let's play with the basic twisting skin of the building. All right, so angle of rotation should be around 2 to 9, 2 to 10. Otherwise, it will be too much and the geometry might break. So let us divide the output that is coming from the distance 2 points. Just a quick refresher, the distance 2 point is simply the distance of this attractor point from all the different grid points, and this distance will be associated with the parameter of that tower. So this distance will be related to, let's say, the height of the building or the twist of the building. Okay, so since the number is big, I am dividing it by, let's say, 10. If I divide by 10, it will be 12.3 degrees, 9.1 degrees, 4.1 degrees. So I think that would be good. And I'm going to connect this with my angle of rotation that is going in here. So instantly this is working without any need of troubleshooting or adjustments. Let me put this in here. And I'll turn off the points. Okay, so all these graph tree, flatten tree also show the points. I had to remove 2 relays and turn the preview off for flatten tree and graph tree to remove the points. Okay, you can see that the tower that is furthest away has got the highest angle of rotation. The tower which is closest to it has got smaller angle of rotation. Let me change the position of our attractor point and see how it works. And you can see how quickly it is working now because I have removed all the extra geometries like balcony and slabs. Brilliant. So this one is almost unrotated and this one is rotated like twice. Awesome. Let us connect the height of the tower to the same logic. In this case, we are working with number of floors. I'm going to round them off somehow. Before that, let us see what should be our division factor. The values that are coming out are reaching 170, almost 200. Let's take 20 to be the maximum number of floors. So I think divided by 10 again will be a good number. Change input, put it here. Let's see what is coming out of our division. Zero, 6, 12, 6, 8, 13, 12, 13, 16. So I think this is good. I'm going to put that here. So they are going to round off. Let's check. All the numbers are perfectly rounded. And then I'm going to put it here. Now you can see that number of floors is being used by 2 nodes. So of course I can connect both of them here like this and then this, but a better way would be to press Ctrl and Shift and then do this. So that will do the same thing. Now you can see that there is no building that has popped up. What is happening over here? Null function or function signature mismatch. Oh. So this was coinciding with one of the centers, so the output was 0. And I think we've discussed this before as well, that if it is coinciding, then it will not work. But perfect, this is working. All you have to do is keep the data structure same when it gets into one of the nodes, so that the node can understand how to correlate these different inputs that are getting inside. So the towers that are closer to the sphere, to our attractor point, have less number of floors and less rotation twist per floor. And as it goes away, you can see that it is much more. And if you want to increase a base value for both of them, you can simply add certain number to it. I want to do that for the number of floors because we are not able to see the angle of rotation at all in these smaller towers. So I'm going to go to my this or distance between 2 points. We divide it by 10, we round it off and then use it as our number of floors. So I'm going to add certain number. Let's say 5 number of floors is the minimum. What you just saw is a shortcut where, let's say I know that I need to add 5 and that's the fixed number. So you can do +5 and then select this addition. Automatically B will have 5 in it. You won't have to enter it manually. All you have to do is just connect with A. I did the same thing here and I connected A. So all the numbers are now increased by 5. All the floors are increased by 5. Let me disconnect this, put it here first and then connect it here. Okay. And the twist is interesting. Let me enable the other aspects of the building. Let's just enable all of them. Interesting. And let me hide the internal geometries. Okay, so we only have the material nodes turned on. Awesome. So yes, this is how we connected two different logics, two different scripts, how we connected the parameters of one with the other, and then how did we do some troubleshooting, how did we manage all the different data structures. It was very interesting to troubleshoot the errors that popped up. I'm glad they did. So that was an interesting one. So this will conclude this 7th tutorial, and hope you liked it and found something helpful. See you in the next one.